Hello, thank you for checking out A1 Math, and today we're looking at end behavior on exponential functions. So let's begin. So first I want to start off with our exponential function, which is y is equal to ab to the x. And the two numbers I want you to focus on is the a and the b. Okay, so we want to focus on whether the a is a positive or negative number, and we want to focus on whether the b is greater than 1 or in between 0 and 1. And when that happens, you get different shapes to your exponential function. So when your a is greater than 0 and your b is greater than 1, you get a shape like this. When your a is negative and your b is greater than 1, you get a shape like this. When your a is positive, but your b is between 0 and 1, a fraction, your shape looks like this. And when your a is negative and your b is a fraction, you get a shape like this. Okay. Now, the next thing I want to talk about is the end behavior when dealing with these functions. So what I want you to be able to do is determine what's the end behavior. So what is end behavior anyway? Well, let me explain. End behavior, basically, to sum it up, is what happens to y as x goes to positive infinity and negative infinity. So what is that? Well, let me show you. All right, so this is a coordinated plane, and this is the x-axis right here, and this is the y-axis. Okay, so when I say infinity, I mean going as far to the right as you can go. That's positive infinity for x. And as far left as you can go is negative infinity for x. For y is as far up as you can go for positive infinity, and as far down as you can go for negative infinity. So what I want to know is if your graph goes to positive infinity for x, what does it do for y? And when it goes to negative infinity for x, what does the y do? So let's take a look at this example here. So in this graph, as I go this way with x, as I go this way with x, this keeps going up. Okay? So as far as I go, this will keep going up. So as x goes to positive infinity, y goes to positive infinity. All right. Now, as I go to negative infinity, y is getting closer and closer and closer to 0. So as I keep going this way, it's not going below. It's not going to negative. It's steady getting closer and closer to 0. So as x goes to negative infinity, y goes to 0. And that's what end behavior is. And the most important thing to remember is if you know whether your A is a positive or negative number, and if your B is less than or is greater than 1 or greater than 0, in between 0 and 1, you could determine the end behavior just by looking at the A and the B. But I'm going to go through the rest of these, and then we're going to do some problems. So let's take a look here. So as x goes to positive infinity, y goes to negative infinity. And notice you don't have to put positive on the positive infinity. And as x goes to negative infinity, y goes to 0. All right. On this one, as x goes to positive infinity, y goes to 0. So the more I go this way, y gets closer and closer and closer to this line, but never passes. So it's going to be uh, 0. And as I go this way with the x, Y keeps going up, up, up to positive infinity. All right, so as x goes to positive infinity, y goes to 0. And as x goes to negative infinity, y goes to negative infinity. Okay, so the next thing I'm going to do is show you what that looks like in a problem. Okay, here's an example of a problem that's already worked out here. So we're going to have the function f of x is equal to x raised to the, 2 raised to the x. Excuse me. So what we want to be able to do in this problem is determine what the a is, the b is, the y-intercept, and most importantly, find the end behavior. Okay, so we got 2 raised to the x. Okay, so it doesn't have the understood 1 that's in front of it here. So we know a is going to be 1, and 2, which is that has the exponent on there, that's going to be your b. Okay, whatever your a is, if you put 0 in front of it, that's going to be your y-intercept. So if you're given the function, then you can find a, b, and the y-intercept really easy. So the main thing you want to do is be able to find the end behavior. Okay, so this is what you do. You type in some numbers here, and you usually use these numbers here: -1, 0, 1, and 2. You plug those into your function and get your y. Same thing we did in previous videos. Then you plot out your points like so. Draw your graph, and then to tell me what the end behavior is. Well, it's x, and this is telling you what it says, but what I want you to be able to do is just write it out. As x goes to positive infinity, what does y do? As I go this way, what does the graph do as far as y? It goes up and up for positive infinity. And this one, as x goes to negative infinity, y goes to 0. It gets closer and closer to this line. All right, let's work one out. Okay, so on this example, we want to do the exact same thing. We want to determine the a, b, and the y-intercept. So I've got the function here, and it's 3. F of x is equal to 3 times 4 raised to the x. So we already know that the a is going to be 3, and the b is going to be 4. So since we know the a, all we got to do is put 0 in front of here for our x, and the y-intercept is going to be 0, 3. Okay, now what we want to do is determine the end behavior. So I'm going to plot out the points. So what you want to do is take your calculator, clear this out, and just plug in -1, 0, 1, and 2. So you got 3 times 4 raised to the -1. Okay, so you get 3 over 4. Okay, and so once you get 3 over 4 here, I'm going to put it as a decimal, 0.75. And then you just fill in the rest of them. You plug in your 0, your 1, and your 2. And you'll get 3, 12, and 48. All right, now I'm going to graph that. So just a moment. So I got -1, and it's at 0.75. It's almost right on there because it's a real small graph here. And then at 0, 3, that's like right here. And then at 112, up here. And then 248 is way up here. And now we have a graph. All right. And even though I went past the line, that's just me drawing. It's never going to get to past 0 here. So, and just because we've got the two things we need, our A is positive and our 4 is not a fraction. So we know we're going to have your X as it goes positive, Y is going to infinity. And as X goes to negative infinity, Y is going to 0. Okay, take a look at this number here and see if you can solve this one. Okay, this should be what you get. Your graph should look like this, and it's going up, and same as before, since you have a uh, positive A and a B that's a greater than 1, then you're going to have a in behavior as X goes to infinity, Y goes to positive infinity, and as X goes to negative infinity, Y goes to 0. Okay, let's take a look at another example. Okay, now on this example here, our A is going to be negative. So we've got a negative A here, and our B is still a whole number, greater than 1. So we've got A is equal to negative 2, and B is equal to 3. And I say whole number, but as long as it's greater than 1, you're good for B as far as it being like this. Okay, so since we know that, we know our y-intercept is going to be 0, negative 2. You plot out your points here, and then you make a graph, like so. Okay, and on this graph, it's going to go as x goes to positive infinity, y goes to negative infinity. But as x goes to negative infinity, y gets closer and closer to 0. Okay, let's take a look at another example. All right, so again, we've got the negative for our a and a number that's greater than 0 for our y. So we're going to plug in the a, which is negative 3, and plug in the b, which is 4. All right, then the y-intercept is going to be 0, negative 3. And now we just need to find these points here. So what we do is take the calculator and plug them in. And once you do that, you'll end up with negative 0.75, negative 3, negative 12, and negative 48. And then you're just going to plot it out on your graph over here like so. Okay, for negative 1, it gets real close to 0.75. Okay, and then at 0, we're at negative 3. At 1, we're at negative 12. And at 2, we're at 48. Our graph is kind of going like that. So as x goes to positive infinity, y is going to negative infinity. And as x goes to negative infinity, y is getting closer to 0. All right, take a look at this next example and see if you can solve this one. Make sure you set up a little t-chart here. You have your x, And your function, f of x is equal to negative 3 times 3 raised to the x. And use these for your domain, negative 1, 0, 1, and 2. All right, so your graph should look like this. It should go as x goes to positive infinity, y goes to negative infinity, and as x goes to negative infinity, y gets closer and closer to 0. Okay, and this is how you graph an exponential function and describe the end behavior. I want to thank you for checking out A1 Math. Have a nice day.